Right, chapter 5 is about aromatic compounds. We've talked a little bit about them. Now we're going to get much more into them, and particularly the reactions with them. So we're going to be talking mostly about benzene ring. This is section 5.1, the structure of benzene. So we've seen that benzene is a six-membered ring. It's what's called conjugated, where you have alternating double and single bonds. And you can draw a resonance structure where the pi bonds can actually resonate around the molecule. So technically an equivalent compound. These are the same exact compounds. There's nothing that is like different about them. It's just the location of the pi bond, but it's still the same molecule. So we've seen that a more common way of drawing this would be with a circle in the middle. I'm not going to draw it with the circle in the middle, but when you do see that, you'll know what that means. Now, last chapter, in chapter 4, we learned a lot about reactions with pi bonds. Okay, so I can take a pi bond and I can do various reactions, like I can add KMnO4 in hydroxide, sodium hydroxide, and I can get a cis diol. Okay, this is one of the reactions. Another one is doing hydrogenation on platinum oxide to hydrogenate off our double bond. We've learned adding HCl, adding acid. We've learned various reactions. Well, if I were to do the same exact reactions to an aromatic ring, so if I were to add KMnO4 and hydroxide, I would get no reaction. If I try to hydrogenate this, I get no reaction. If I do any chapter 4 reactions, RxN is reactions, shorthand. Any chapter 4 reactions on benzene, you will get no reaction. Okay, so why? What's so special about benzene that I can't do any of these reactions? I mean, technically I have 3 pi bonds on this aromatic ring. Why can I do it 3 times? And that's because of this resonance stability. Okay, that's how important resonance is. Okay, resonance is such a stabilizing effect that it takes more energy to break. More energy is required to break apart the aromaticity. Make apart aromaticity. Okay, so much energy is required to break up that aromatic compound that these typical reactions can't do. They just can't do it. So there's only a handful of reactions that we can do that we're going to learn in this chapter that are very specific and very special for aromatic compounds.